In this lecture, we're going to continue looking at logic and conditionals in MATLAB. The first thing we're going to look at are logical variables. We can create logical variables using rational operators. We can combine rational questions with logical operators. We can use logical variables to perform manipulations on other MATLAB variables. Logical variables can be scalars, vectors, or multiple dimensional matrices. They contain only the values 0 for false and 1 for true. They're created using rational and logical operators. You can also create them using certain functions such as isNumeric and strcmp. The assignment operator is used to place the result of the question into a variable. So again, single equal sign does not mean equal to in MATLAB. And it can be used in mathematical operations, so using a mathematical operator to modify a logical variable usually converts it to a numerical variable. So we got to look at the order of operation as priority. So arithmetic operations have priority over all rational operators. Rational operators have priority over logical operators, and standard logical operators, which are your single and your single or, have priority over your short circuit operators of your double and your double or. Also, as a reminder, and has a priority over or. So there's table 18.1 has more details on that. So let's look at this example. We have some variables defined in MATLAB already. If I say too big is equal to volume greater than 1 e to the 5, what it's going to do is it's going to go through volume and find every instance that is greater than 1 e to the 5. If I say mag too big is the absolute value of volume greater than 1 e to the 5, it's going to go back through volume and look for things that have a magnitude that is greater than 1 e to the 5. If I say V2 bigger, so I want to figure out where V2, volume 2 is greater than volume 1, it is going to compare them element by element to figure out which ones are bigger. If I say lowercase equals MSG greater than or equal to A and MSG less than or equal to Z, it's going to look for letters that are between lowercase a and lowercase z, so you can actually find the lowercase letters, because remember, every letter in MATLAB has a value. So how can we manipulate these values using logical variables? So if we were going to replace all the negative values in m with zeros, I can say m is equal to m times m greater than 0. The parentheses are only for clarity. I want to replace all positive values of n with 999 and all negative values with -1. 0 should be unchanged, so what I can do is I can say n greater than or equal to 0 times 0.99 minus n less than 0. Divide all values of p greater than 100 by 2. So I'm going to say p is equal to p times p less than or equal to 100 plus p greater than or equal to 100 is times p divided by 2. So we can compare text. We have the string compare and the string compare I function. So if I say if a is equal to yes, I want w equals 2, else w is equal to 3, and this is going to be the topic of the latter half of the lecture. So if a is equal to yes, then we get w is equal to 2. If a is equal to capital S, we would get 3. If a is equal to capital Y lowercase es, we would get 3. And if a is equal to no, we would get an error. What you can use is your string compare functions, and I want to say a and yes, it's going to compare it in a case-sensitive manner, since again, 2 only is the only one that triggers a true response to get w equals 2, but in this case, n equals no longer brings an error because you're now comparing the strings and not just the length of the characters in the string. If we use string compare I, and we are now comparing it in an in-case sensitive manner, so all the different permutations of the word yes now yield positive results. In this challenge problem, we're trying to combine two equal-sized matrices based on some logic. So if an element in M1 is greater than the corresponding element in M2, that element in B contains twice the value of M2. If the element in M1 is less than the element in M2, we want it to contain the value of M2. And if the elements are equal, we want it to contain the value of m1. Sorry, half of the value of m2 for this middle one. So the way logic follows is it's going to look for certain elements, element by element, and see which part of these statements pass and which ones fail. And you notice they can't pass or fail multiple tests. So now we're going to look at how to build conditional statements. So we're going to predict the number of possible outcomes and actual result of a conditional statement. We're going to determine two conditional statements are logically equivalent, and we're going to utilize single and nested conditional statement structures within a program. So we're going to start looking at our if, else structures in MATLAB. So we're going to look at our if statements in MATLAB, basically. So basically how these work is you write if and you ask a question, then what to do if it is true. Else designates the end of operations completed if the logical statement is true. What to do if it's false, and then end, which ends, this designates the end of our if statement. So it's if, what is our question, what do we do if it's true, else, what do we do if it's false. The question portion can contain simple rational expressions or complex expressions built with combinations of logical and rational operators. So just like we can make our questions in Excel complicated by using our and our or statements, we can do the same thing here in MATLAB. So let's look at a simple if statement. If, insert condition, insert MATLAB code if true. So if I say x equals 5 and I say if x is less than 10, x equals x plus 3, end. That is a very simple if statement. A slightly more complicated one is if, insert condition, insert MATLAB code if true, else insert MATLAB code if false. So if I say m is equal to 20, if m is greater than or equal to 20, m is equal to 0, else m is equal to 1. So it's going to compare the value of m to 20, execute this code if it's true, and if not, it will execute that code. MATLAB converts decimal values to binary numbers. Some decimals end up with round-off errors in the 16th decimal place when converted back to a decimal. So if I type in the command window 1.6 equals fprintf of 0.1.6 fx, I'm going to get the results of 1.6 0. So there's a residual 0 in the 16th decimal place, and this occasionally causes errors. What we can do is I say x equals 1.5, y equals 3, and I say if y equals, remember this is for equality, 3.2 times x divided by 1.6, I want to print yes, and otherwise I want to print no. And then I wanted to print to 16 decimal places the calculation to see if any round-off errors are occurring. So the result is no, because I'm getting an error here where I have a 4 coming into my calculation. So even though this result should give 3, it actually gives 3 point something, 4. The moral of the story is you have to be very careful using equals as a test in if, because it can cause errors in your code that you would be unexpected given the precision that MATLAB carries out calculations to with the 16th decimal point. So how do we nest conditional statements in MATLAB? So again, we have our first question and we have if it's true, we do that. And if we have our second question, we're going to trigger a second if statement. MATLAB has a structure called if, else. So first is your if, where you ask your first question. Then you write your code for what to do if question 1 is true. Then you write else if, which will end question 1 and ask question 2. And then you write the code for question 2 if question 2 is true. Then you write else, which will designate the end of question 2 being true. Then you write what to do if question 2 is false. And then you end your code completely. So let's look at an example here. Based on the user choice, we want to save the food name. So we want to save it in the variable food, and we want to assume the user does not close the window without making a choice. So we're going to use some if else commands. So if the user chooses option 1, their favorite food is pizza. Otherwise, if the user chooses option 2, it's tacos. Otherwise, if the user chooses option 3, it's ice cream. Otherwise, it's spinach. So we have 4 outcomes that requires 3 decisions. So we can use an if, else sequence. So what do we get? Well, I can say if food equals 1, we're going to have pizza. If food equals 2, it's tacos. If food equals 3, it's ice cream. Else, our favorite is spinach, because a menu only stores the numerical value of the button that was clicked and not the text that it contains. Based on the user's choice, we want to save the food name, the text variable. We want to, again, use our if else command, and we want to know what would happen if the user closes the window without making a choice. So we still have our original first 3 commands. In this case, I've updated the else if food is equal to 4 spinach, because I want to update my else command to be if one of these was not chosen, we want to print you did not make a selection. Let's go back and look at our example where we're trying to figure out the phase of water, if it's a solid, liquid, or gas. We want to create this in MATLAB, just like we did in Excel. So we're going to ask if the water is less than 0 degrees Celsius, it's solid. Otherwise, if the water is 100 degrees Celsius or greater, it's vapor. Otherwise, it's a liquid. So we have 3 outcomes and 2 decisions. So we're going to use if, else. You really need to use your English as a guide. The commas separate the conditions from the actions. The semicolons separate the sequences. And the period marks the end of the statements. So let's look at our solution. So if t is less than the solid limit, the phase is solid. If t is greater than or equal to the liquid limit, the phase is vapor. Else, the phase is liquid. And don't forget your end. We can also use a structure of if, else. So I can say if, ask question 1, what to do if question 1 is true. Else, what to do. Else will end the question 1 true code, and then you can put if again to ask question 2. Then you can say else. This will designate the end of question 2. What you do if question 2 is false, and then you can end, and then you can end. So you can do a slightly different form of the if, else, or if, else. We're going to do a comparison of them. We have if, else, if, and if, else, if. So if A is equal to 4 and B is equal to 2, I'm going to ask if A is greater than 3, print my value with 0 decimal places of A. Else if A is less than 5, print my value of B. I'm doing the same thing in here in this code, but I'm still asking the first question, and if it's true, I'm printing it. Otherwise, I'm going to trigger a second if statement to figure out my second question. So they do the same thing. Else if, else if is a little bit more compact than an if else statement. So if we wanted to compare the Reynolds number of a flow and see if it is laminar or turbulent, we can do it again with is-else and else-if. So first question we ask is our flow less than 2,000 to get laminar flow? So the first is always the same. Then I ask if it is greater than 10,000 for turbulent. In this case, I have to say else, then if, and ask my question again. And then the end is the same, where we have our else if both of these are false, where we write transition. This requires 1 end, this requires 2 end. Again, they are doing the same thing, they just run slightly different versions of the code, so they take slightly different time. It's not like you're going to yield incorrect results doing one or the other. This is much more akin to how we had nested if statements in Excel. So errors and warnings that might occur, we want to understand the differences in the uses of the error and warning functions, and look at the try and catch to prevent abnormal termination of a program. So error and warning are 2 functions. So error prints a custom error message on the screen in red and terminates the program. Warning puts a custom warning message on the screen in orange and continues the program with the text in the next statement. So I want to ask the user to enter their age in years, and if the user enters a negative number, I want to warn the user and use the absolute value. So I can say age, I can ask them to input their age, and I can say if age is less than 0, print a warning, and then take the absolute value of the age. If I ask the user to enter the circumference of a sphere in the units of centimeters and I want to determine the volume in liters, if the user enters a negative value, I can display an error that terminates the program. So I can ask the user to input the circumference. If the circumference is less than 0, I will prompt my error, which will then end my code. Otherwise, I will continue with the else part of my code and calculate the volume. So you can use if statements to modify your codes that require user input to make sure things are occurring the way that they should be. If we look at our solid, liquid, gas code again, if the user inputs a value that is outside of the range of absolute 0, so if they put in a negative number, we're going to tell them that the temperature is not possible. And then if the user puts in a good value, we're going to run our original code for figuring out the phase of the liquid. So what did try and catch do? Try begins a block of code in which an error might occur. So it's try and the code possible errors goes there. Catch ends the block of code, specifies the name of the structure into which is placed the information about the error that occurs and the block of code for custom handling. And then end marks the end of your try catch code. So some notes about try catch. The try code only executes up to the line where an error occurs. If there is no error, all of the try code executes and the program continues below the end statement. Structure name is a structure array in which information about the error that occurs, if one occurs, is stored. The catch code only executes if the try code causes an error. The catch code might terminate the program with the error function or continue the program after optionally issuing a warning. So for example, I can say try input, I can ask the user to input M1, input M2, and do the product, where catch might cause an error if the warning and error has occurred, and then print the error message. And then this would end, and I can say the code would continue from here, assuming that this product causes an is not capable of being calculated. So for an example, let's look at this code. So if I enter the matrix 3, 5, 2, 6, and then the matrix 4, 6, 8, 9, we're going to get an error because these cannot be multiplied that way. So in line 6, I want to get an inner matrix dimensions must agree. Code will continue from here. So try and catch can catch some errors. So this concludes our look at logic in both MATLAB and Excel. The next topic we're going to look at are for loops and while loops in MATLAB, which allow you to execute the same portion of code over and over again until a desired result is achieved or a fixed number of iterations occurs.